factoring by grouping. So let's roll. First thing we want to do again is we want to be able to get the GCF of all of the terms. So first thing I look at are the coefficients, which are just the numbers. So let's get the GCF of 24 and 36 using my GCD function. So I'm going to hop right over there and I'm going to do math, number, 9, and then I'm going to put 24, comma, 36. And that gives us 12. And let me hop right back over there. And I'm just going to put the 12 up top here because I know that's the GCD of these two. Now I'm going to get the GCF of 40 and 60. Okay. Again, I'm going to do math, number, then a 9, then I'm going to put 40, comma, 60. And it's 20. And last but not least, I'm going to do the GCD of 12 and 20. Okay. So I'm going to do math, number, 9, and I'm going to do GCD of 20, 12 and 20. So 20, put it first this time, and 12. And there it goes, it's 4. So now I know 4 is going to be the greatest common factor, or at least part of it. I'm going to skip a space and I'm going to write my 4. But I'm also going to notice here that do they have a letter that's in common? Well, it looks like it. I'm looking at X here, but this one doesn't have an X. Well, what about Y? Y is here. It's not for all of them. If there was, then I would definitely factor that as part of my GCF as well. So I'm going to open my parentheses, and I'm going to divide everything by 4. 24 divided by 4 gives me 6. Then I'm going to bring down my X and my Y. 36 divided by 4 is going to give me 9. And then we're going to get that X squared plus 10. And then we're going to get Y to the third. And then we're going to get plus 15 Y squared X. Questions so far? From here now, we always want to remember first, let me just bring down this GCF so I don't forget it. And then I'm going to factor what's inside. What method do I use is always determined by the number of terms. So I'm looking at here, I got 1, 2, 3, 4 terms. Split it down the middle and factoring by grouping. GCF between 6 and 9 we know is going to be 3. Well, do these terms have anything else in common? X. So I know I'm factoring out 3x. I divide by 3x here. I divide by 3x here. Then it's going to give me 2y. Then 9 divided by 3 is going to give me positive 3. And last but not least, x squared over x. What do we do with the exponents when we divide? That's right, we subtract. 2 minus 1 gives us 1. So it's just going to be x to the 1 or just x. Same thing on this side. Between 10 and 5, I know my GCF is positive 5. And if you didn't know, you could still do the GCD function like we did in the beginning. Then I look on both sides. They both have a y. Well, what's the smaller exponent available? Y to the second. So I know that's going to be also part of my GCF. Now I'm dividing everything by my complete GCF. Quite often, your complete GCF might not just be a number, but a number and a variable with an exponent. 10 divided by 5 is 2. Y cubed over y squared is y. Plus 15 divided by 5 is 3. The y squareds cancel out. And we're left with x. If your parentheses are not the same, something's wrong with one of your GCFs or your division, so double check back. Once we got that common parentheses, we can bring it down. 2y plus 3. And then the next one is going to be 3x plus 5y squared. All right, catch you on the next one.